Example 8 says, let point A, -3, -6 be the endpoint of a terminal side of an angle theta in standard position. Compute the following. So -3, -6 is going to be down here. So we're in quadrant 3. So that's telling you the end of the terminal side. So you draw this back to the origin, and now we'll form a right triangle with the x-axis. So the angle of this is the same thing as the sine of this angle, the interior angle of the triangle, is the same thing as the sine or cosine of the angle from standard position. So we always mean with respect to the x-axis. So we know from a point to get to this location, I have to go -3 in the x direction and -6 in the y direction. So this side is length -3, this side is -6. Once again, to get my hypotenuse r, I do the Pythagorean theorem. So -3 squared plus -6 squared equals r squared. 9 plus 36 is r squared. 9 plus 36 is 45. So the square root of 45 is r. So tangent is opposite over adjacent. So the opposite side is -6 over the square root of 45. Secant is hypotenuse over adjacent, because it's 1 over cosine. So the hypotenuse is the square root of 45, and the adjacent side is -3. Part B of this problem says we'll let 7 be the endpoint of the terminal side. So we go over +4, down +7, and once again I draw a line from the origin to that point. We always take the triangle to be with respect of the x-axis. So here's our angle alpha. So we go to the right 4, down -7, and once again we're going to use the Pythagorean theorem to get our hypotenuse. So this is going to be 4 squared plus -7 squared equals r squared. 16 plus 49 is r squared, and this works out to be 65 is r squared. So the square root of 65 is r. So cotangent of alpha, remember tangent is opposite over adjacent, so cotangent is adjacent over opposite. So the adjacent side is 4, the opposite side is -7. Sine is opposite over hypotenuse, so the opposite side is -7, and the hypotenuse is the square root of 65. Find all the possible values of sine of x in the interval from 0 to 2 pi when cosine is 5 over 7. There may be more than one right answer. So if cosine is positive 5 over 7, remember those are the x values, there are 2 places from 0 to pi, that's one trip around the circle, where cosine is positive. It's positive in quadrant 1, and it's positive in quadrant 4. So x could be this angle or this angle. Cosine is adjacent over hypotenuse. So the adjacent side to the angle is 5, and the hypotenuse of each of these triangles is 7. So now I'm going to use the Pythagorean theorem to find the missing side. So 5 squared plus y squared, because they're y values, right, equals 7 squared. So y squared is 49 minus 25, which is 24. But now when I take the square root, remember I'm not finding the hypotenuse this time, I'm actually finding a y coordinate. So I actually get plus or minus the square root of 24. So in quadrant 1, this triangle has a height of positive square root 24, but down in quadrant 4, it's negative because y values are negative down there. So now if I want to find sine of x, well, that's opposite over hypotenuse. So in quadrant 1, that's positive square root of 24 over 7, but in quadrant 4, it's negative square root of 24 over 7. And so the reason I had to check both quadrants was it told me to check all 4 quadrants of the unit circle. That's what 0 to 2 pi means.